Sorry, Bob. Let's try it again. Okay, good morning. This is the August 12th, 2025 meeting of the Hudson Valley Regional Board of Review. And this hearing is being held via video conference call on location, Cortland Town Hall, 1 Henry Street, Cortland, Mass, New York, 10567. Time is now 9:45 a.m. and this hearing is officially open. The members of the board are Megan Smaler to my right, Jane Bedell to my far right, Jane Slavin to my left, and attending remotely is Mark Kavanaugh. My name is Mark Arginarelli. I'm the chairman from the Department of State. We have Erica Krieger way off to my left, and Neil Collier also way off. We will now hear the scheduled petitions. When you speak, please address the board and give your name, title, and legal address so that our court reporter can have all the information requested. We may have to stop from time to time to consult with our technical staff. In making comments to the board, please provide a descriptive narrative on a matter referring to your exhibits. Enable the court reporter to enter these into the record. Specifically, what that means is if you're going to, I know you guys have a lot of exhibits and drawings, so please, when you're referring to a particular exhibit or drawing, please make sure you reference that drawing or exhibit number. Okay, the first petition is in a matter of, the first petition is petition number 2024-0596. The agreed party is Stanell Properties, number 600 LLC. The petition pertains to variances in connection with the proposed development of a new e-commerce storage and distribution center for consumer products. Occupancy S1, moderate hazard storage with a footprint of approximately 652,060 square feet, 5 stories in height, for a total of approximately 3,232,740 square feet. Construction type 1A, fire resistant, and located at 22 McBride Road, Town of Wayanda, County of Orange, State of New York. The petitioner is seeking relief from 19 NYCRR, Part 1221, the Building Code of New York State, Section 602.1 and Table 601, which states, buildings and structures erected or to be erected, altered or extended in height or area shall be classified in one of the 5 construction types defined in Sections 602.2 through 602.5. The building elements shall have a fire-rated resistance not less than specified in Table 601, and the exterior wall shall have a fire resistance rated not less than specified in Table 602. Where required to have a fire resistance rating by Table 601, building elements shall comply with the applicable provisions of Section 703.2. The protection of openings, ducts, and air transfer openings in building elements shall not be required unless required by other provisions of this code. The petitioner is seeking relief to allow the use of an alternate method of fireproofing the steel frame. 19 NYCRR, Part 1221, 2020 Building Code of New York State, Section 1017.2 and Table 1017.2, 19 NYCRR, Part 1225, 2020 Fire Code of New York State, Section 10, I read it, I apologize. Which states, exit access travel shall not exceed the values given in Table 1017.2. Table 1017.2 provides if required, exit access travel distance for an S1 occupancy with a sprinkler system to be maximum of 250 feet. The petitioner is requesting relief from an exit access travel distance of 250 feet maximum to be 400 feet. 19 NYCRR Part 1225, Fire Code of New York State, Section 5003.1.1, maximum allowable quantity per control area. It states maximum allowable quantity per control area shall be as specified in tables 5003.1.1 subsection 1 through 5003.1.1 subsection 4. The petitioner is seeking relief to allow an increase of maximum allowable quantities for floundering and possible liquids. Okay, someone here that's going to present the case. Please, before we start, say your name and company and address for the recorder.
Do we need to touch this at all, or is this,
No, you can.
this is on? Okay. My name is Kim Mason, and this is Nancy, A-S-O-N. I'm an attorney with Phillips Lytle, L-Y-T-L-E. The address is 125 Main Street, Buffalo, New York, 14203.
And I'm Nolan McCarthy, with Harrington Group, the fire protection engineering firm on the project.
Just wait a minute.
Nolan, N-O-L-A-N, McCarthy, M-C-C-A-R-T-H-Y. Harrington Group is located at 3237 Satellite Boulevard, Suite 525 in Duluth, Georgia.
Okay.
All right, so we received your submission, and then there was an updated submission that was submitted subsequent to that. We all received that.
Okay, great.
So if you could just go through and summarize it.
Sure. So as I mentioned, my name is Kim Mason. I'm the attorney for Spinell on this application. Also with me online is Linda Netto, another attorney from my firm as well. And Nolan has introduced himself already. We also have Grant Gephardt with Harrington as well, and Matt Boone from Spinell Properties. So at any point, if there's any questions, you have all of us to answer. I also believe that Chief Graham from Slate Hill Fire Department is with us on the WebEx as well. So I just want to thank him for participating. We've taken, I think originally about a year ago, August of last year, we started our outreach and communications with the town and with the Orange County Emergency Services Department to present some of the information that we'll talk about today on the performance-based design, run through what this application looks like, what the variances are. So I just want to thank the town for working through this process with us. We met with DLS staff as well, so thank you to DLS. In the most recent filing I sent in, I believe last week, we included a letter of support from the town supervisor, the code enforcement official, and Chief Graham. So thanks to them for their assistance as well. I'm just going to give basically a high-level overview of the project. I'll touch on what our variance request is and what our proposed justification for the variances are in our filing, and then I will turn it over to Nolan, who will get more into the technical aspects of the design of the facility and its performance-based design. So as mentioned, we're dealing with the development of a proposed e-commerce storage and distribution facility, which will be located on about 81 acres at 22 McBride Road and will be occupied by a single tenant. The facility has a footprint of just over 650,000 square feet and will consist of 5 stories. So we're looking at total square footage of just over 3.2 million square feet. It is an S1 occupancy, concrete and steel construction with automatic sprinkler construction throughout. Importantly, this project is anticipated to employ at least 750 people, and that's actual operational jobs, not counting construction jobs. And this will have a significant positive impact on the tax base and the local economy, and these variances are required as a gating item for the project to go forward. So we're requesting variances from 3 separate components of the code. There was an initial submission in November of 2024, which has, as I believe, Exhibit B, the performance-based design that we're talking about here today. It was updated in May 2025, and you received that, as the chair mentioned. Really, the only difference between those two filings is there were some internal, relatively minor design updates to the building, and as such, some of the analysis and modeling that's included in the performance-based design needed to be updated accordingly. But between those two filings, there's no change in the substantive application, not the variances we're applying for, the justification. It all remains the same. It's an update to basically the modeling that was done in the PVDA, and we can answer any questions on that as well. All three variances that we're here for today have been issued before and approved for other facilities. The first two, with respect to exit access, travel distance, and the fire resistance rating, have been issued multiple times all over the country, and I believe at least 6 times in the state as well. And there's, as I probably all have seen, some conditions that have been developed throughout those applications with the Department of State that would apply here as well if the board wants them to. And then the final variance request with respect to MAQs was recently approved in May by the Albany Board of Review for a similar facility in the town of Florida, New York. So first, as I mentioned, we have this performance-based design, which we'll get into a detailed description of, but that really is the justification for all of the variances we are requesting. It is based on that design. The first variance is with respect to exit access travel distance, and this is really connected to the size and the layout of this facility that's necessary for its operations and kind of just a prototypical design for this tenant. This includes a building length of over 550 feet. And the tenant operations rely on large open floor plates for storage, and that's what brings us to the exit access travel distance request of 400 feet. As compared to 250, which is usually required. Next, the second variance is related to the fire resistance rating required for type 1A construction of the structural steel components. I'll get into this in a minute, but the traditional methods of fireproofing for this type of project are not viable due to time and cost impacts, and also potential impacts to the sensitive robotics that are really essential to how the facility operates. And then finally, the third variance with respect to MAQs. Excessive use of storage and distribution of certain retail products for online sale, goods specifically that are classified as either flammable liquids, class 1B and 1C, not 1A, or combustible liquids, class 2, 3A, and 3B. And really due to the scale of the facility and the prototypical layout, we're proposing storage in amounts greater than are typically permitted under code, and we'll get into what we're proposing in terms of some limitations that go along with that. So next, turning to the criteria for approval, there are 4 under the regulations that we're specifically referencing. The first one has to do with excessive and unreasonable economic burden. So in the analysis that was done for these facilities and this facility specifically, the cost of complying with the fire resistance rating requirements, the estimate is over $80 million for this type of facility. In addition, it is estimated that this would add approximately 6 to 8 months of construction time to complete traditional fire resistance rating requirements. If the structural steel had to be fireproofed under one of the traditional approaches, this could cause an impact to schedule and render the facility unable to meet the tenant's capacity needs for occupying the building in 2027. Next, we have achievement of important public policy. As I mentioned, this project will create at least 750 jobs and will, achieve social and economic goals of the state and the region by improving the tax base of a site that has been targeted for development. The next justification has to do with physical impracticability. I mentioned that a little bit. So for both the exit access travel distance and the MAQs, that is very much connected to the length of the building and the size and the logistics of the layout that no one will get into. But also, with respect to some of the traditional methods of fireproofing, there is concern with the sensitive robotics of the facility. Specifically, if you were to fireproof using cementitious spray, this could potentially come off over time, especially with some of the vibration that is anticipated to be present at the facility. And there is a concern that this could coat the floors and damage the robotics which run along the floors and move the storage pods. And then finally, perhaps most importantly on the justification, we submit that the code compliance, I should say compliance with prescriptive requirements, is unnecessary in light of this alternative design that we're talking about, which achieves the intent of the code without. That's again connected to the PPPA that we'll get into, the significant improvements to sprinkler system performance, reliability, and duration. And this is for all three of the variant requests. And we submit that the proposed alternative design would provide an equal, if not greater, level of safety. And so finally, just to reiterate, these variances are essential to the project moving forward. I will now turn it over to Nolan, who will get a little bit more into the details unless there are any questions for me in the meantime.
What we'll do is, after your presentation is over, we'll take questions from the board.
Thank you, Kim. Nolan McCarthy with Harrington Group, the fire protection engineering firm on the project. So I think, Chair, I think you exhibit B, if I heard Kim correctly, is the entirety of those files is red one, the performance-based design analysis, dated May 28th of this year. So we'll kind of go through that. I'm not going to necessarily cite things until you guys have questions, and we can flip to a specific page. But I'll just kind of give a quick overview and get into some technical details of the approach here. So again, the three main code sections that we're seeking an alternative design to are Type 1A construction with the typical passive fire resistance rating approaches that the code typically prescribes. The second one is the exit access travel distance, because we don't comply with the ceiling height provision of that code section. We can't technically say we're prescriptively compliant there. And then the third is the maximum allowed quantities for select hazardous materials limited to the final combustible liquid subcategories that Kim mentioned previously. So the overarching approach of the performance-based design was really encompassed by two main things. First was full-scale fire testing at UL, so Underwriters Laboratory in Northbrook, Illinois. This endeavor is really an evolution of this facility type of tenant. So that testing really started back in 2018 and has continued subsequently every year since to continue to make sure that the testing directly speaks to the hazards that are in the building. And so there's a lot of technical content that we as engineers hang our hat on that are being brought from that full-scale fire testing at that nationally recognized testing laboratory. The other big piece is fire and smoke modeling with industry recognized FDS is a computational fluid dynamic piece of software where we can kind of analyze large eddy flows of fluid dynamics really around fire and smoke phenomena. So with the Type 1A construction, the approach, instead of doing the typical passive spray applied fireproofing, to Kim's point, there is not so insignificant cost and schedule impacts, but there's also the practical concern of compatibility or incompatibility rather with the robotics that are in the building. So a 5-story building is predominantly conveyance processing, inbound, outbound, everything on the first floor. The other 4 stories above it are more or less copies of one another, to where that's where the storage fields are, and that's where you have kind of a chain link fenced area. The mass predominant space of those upper floors are really unoccupied. They're chain link fence segregated from the perimeter where associates would be located, and that's where the storage fields are. So the pods are about 8.5 feet tall, and there's several thousand of those pods with about 1,500, 2,000 robots on each floor that drive around, that can drive underneath the pods, pick it up, and bring it to the perimeter, where there would be stow or pick stations where associates can perform their job functions. So the testing that was done at UL was really over that predominant hazard that is the 8.5 foot tall storage pods. The testing conformed to industry standards, including NFPA 13 and UL testing protocols in terms of ceiling height, ignition location relative to sprinkler parameters and everything. So we can go into detail there in the report later. But all of that followed industry standards. We weren't trying to reinvent the wheel any way. We were following industry standard care for those testing protocols. And what we really wanted to achieve with the testing for the type 1A construction is to really make sure that there's not a structurally significant fire. Performance-based design is not purporting to guarantee fires won't happen, and it's not purporting that we will extinguish fires. The fire department will still have to come and perform their tactical duties once they arrive on the scene. But in lieu of the passive protection systems, our goal was to make sure that the fire was really reasonably can be suppressed and backed by that full-scale fire testing, which again looks at several different variables, ignition locations, et cetera. In addition to the robust sprinkler design above and beyond what that hazard was generally called for from a code perspective, we wanted to make sure that we had reliability and redundancy. So the water-based system in this building, when you normally would just have to have one supply, minimally designed fire sprinklers for the hazard, we've increased that design to really make sure we're suppressing it. There's 2 water supplies, there's 2 loops, there's 2 fire pumps to really make sure that the reliability of those already pretty reliable wet pipe sprinkler systems are even more so reliable. And so you've got 2 completely independent water supplies sizes if the other one wasn't there. And both of those water supplies feed all of the interior water-based fire protection systems. So if something were to happen, some sort of single impairment, when the code contemplates it, that you need to account for a single impairment, you can still address that as if that was the only system there, but on back of that, you've got a whole completely redundant system inside, independent of the first. In those designs, there's some conservatism and some safety, and we can go into that, but generally, the fire protection, the water-based design is to summarize that part. It's the robustness, increased design, the reliability, and redundancy there. The duration of the water supply is also part of this, so, for example, this site will have at least one on-site water storage tank. The duration of that water supply is typically, from a code perspective, only a 1 or 2 hour duration. But because of the type 1A construction type, the highest fire resistance rating associated with that is a 3 hour duration. So the water supply duration is increased from the minimum 1 or 2 hours to the 3 hours to kind of align with that perceived duration from the passive systems. And to jump to the third request is what we call the FC liquid, the final combustible liquids. That was also full-scale fire tested at UO. So we tested the hazard without the liquid. So it's really that the fuel hazard that was tested there is a conservative hazard mix from the testing protocol compared to what would actually be expected in the building. So the testing fuel load was nothing but polystyrene cups. So everyday plastic. And then we also tested that same configuration, but we put the amounts of final combustible liquids in the pods and ran the test all over. Again, I mentioned the evolution of this over the many years of doing it. We've had some of the testing on that in 2018, 2019. And then the hazmat testing that we've done was more recently. So we needed to, with the tenant, ensure that the existing performance-based design that we already contemplated wasn't being lessened by including a new liquid fuel hazard. So we were able to satisfy ourselves that the addition of those liquids, retesting it as well in accordance with the same protocols, was still satisfying the performance objectives of the design. So that kind of covers the main 2, the big one being the UL testing, kind of sufficing for the type 1A construction and the FC liquids portion. There's a lot of code analysis and kind of equivalent risk theory that comes in the code that we talked about in the performance-based design report. But I won't go into detail there unless you guys have questions later. But on the exit access travel distance, the modeling comes into play, and it's connected to the full-scale fire testing because those results from the testing then become some inputs that we put into the modeling based on the fire curves that we see, the robustness of the sprinkler systems, and therefore the design fires that we input into the FPS programming. And again, there's conservatisms at various levels in the modeling in terms of what we do on the fire and smoke modeling, but there's also conservatisms built into the egress modeling. And it's an iterative kind of approach to say, run these different fire scenarios in the model, but also run egress models and kind of see where we have the traditional code languages, available safety egress time versus required safety egress time, making sure that we've got an adequate buffer there for temporary egress. One of the conservatisms that I'll note now is that what we model is a full building code compliant occupant load. So even though many areas within the building aren't occupied, predominantly the upper 4 stories where you're going to have people around the perimeter of the facility, you have very limited folks who actually can have access to that chain link fence on storage field. It's really a maintenance type of thing. So maybe on any given shift, you have half a dozen people per floor would actually be trained and have access to get into that chain link fence area. From a modeling perspective, Tim mentioned we had at least 750. I think from a modeling perspective, this design contemplates 7,000-ish, right? So we're taking the full robust S1 calculated building occupancy, dispersing that randomly through the entire facility, even those areas that are normally unoccupied, and we're running models that way. So from the occupant load, from the egress systems that are designed to carry that 7,000+ people, from the travel distance that those folks are going to have to traverse and the time it takes to do that. And as you can imagine, when you have a large group of people starting to get into a given stair, right, there's a queuing in the model because you have to wait while people flow through that opening. All of that is built into the model to then for us to compare what do we have available versus what's required in terms of the safety. And kind of to summarize quickly, the results of that are such that we feel that there's adequate safety where we're meeting or even exceeding the intent of the code of these performance-based design alternatives.
That's it?
That's it for high level summary. Unless you guys have questions, I can go into these.
All right. Do you want to start us off or?
Sure. Questions. So it's stated that the increase in cost for the alternate or the traditional fire rated system would be $80 million. What's the cost of constructing the facility in general? Or what percentage of cost are we talking about here that would be an increase?
So you have to come up and just put the state name for the record.
Just trying to get an understanding of the percentage of increase in cost that would create.
So Matt Boone with Scannell Properties, 8801 River Crossing Boulevard, Suite 300. Matt, MPT, BOOME, Scannell, CANNL Properties. The total cost of the facility is in the magnitude of $450 million.
Oh, that's a fairly significant amount. And and then, so there was kind of mentioned a lot of robotics are used, but are any of the robots, if they break down, are they serviced within that area that has that extra travel distance, or are they taken out of that area to be serviced?
They would be taken off the floor of the upper floors, 4 stories, and there's going to be some maintenance facilities on the first floor. To the extent of what service they do, I can't speak to the specifics of that, but on that first floor, they are going to have what they call R&D, so it's a reliability, maintenance, and engineering. So it's your building engineers, right, your maintenance folks. So they've got a cage off area with tools to fix whatever they break in.
But it generally would not happen in the middle of the floor.
It will not, right? Yeah, so they would have to go pull that robot off that floor. And I'll always kind of go into some of the specifics of the safety protocols there. So the folks that I mentioned that are limited to go in there, they're specially trained folks. They're wearing special vests that they call them Cerberus vests. They have kind of 2 radio frequency to where the system, the machine, the brain, the building knows where they are. They also have a tablet because, as you can imagine, they're going to be walking into a field of moving pods that have a cadence of miles. So they'll define an area that says, don't go here, right? Robots don't go here. So that they have a safe ingress and also a safe egress back out. And so if something happens, they're gonna have to go get that robot and pull it off, and perhaps on a shift change, pull it off the floor with those safety protocols in place and get it out of the way before, and go do whatever maintenance and repair that they would need to do.
Okay, thank you. Perhaps I missed it, or maybe I didn't parcel through it carefully enough, but I was confused in what the amount of increase in combustible storage and flammable storage that we're requesting. What is the actual amount of increase that we're requesting?
So for the liquids, so the codified maximum is you take the baseline NAQ for an S1 occupancy, and then there's two doublings in the prescriptive code if you put it in a sprinkler building,
Right.
and you also put those liquids in
So that's kind of like these.
Yes,
tables,
the
right?
480.
Yeah, 480 and then to the
Yeah.
1320.
So that's the baseline, including the two doublings, so that's kind of a max baseline, if you will,
Right.
for typical occupancies, including this one as an S1. The aggregate asked here is 49,500 gallons. You may refer to table 1 of the revised report on page 2, and that's kind of a summary table on that page. On the bottom of that table, it talks about the prescriptive limitations, but also the aggregate that we're asking for.
Okay.
But, and while you're looking that up, the concept with that approach, we feel is still meeting the intent of the MAQ concept, because we're trying to spread that out, right? So even though the aggregate sounds like a lot, when it's spread out over 3+ million square feet, the fuel density that we have permitted is based on the full-scale testing, which has some conservatism. For example, we're asking for 60 ounces per pod. We've tested 120 ounces per pod. But so this 60 ounce per pod, the square footage of a pod is a 3x3, it's a 9 square foot pod. So you have a 0.05 gallon per square foot type of liquid fuel density spread across a very large area. So from the sprinkler system's perspective, and from a fuel hazard, fire hazard perspective, it's not a substantial uptick in the overall fuel hazard that was full-scale tested. But on the aggregate of what we're saying we would like in the building, on paper, we recognize that it is a significant increase over the code.
And textually, considering the size of the building, you're saying it doesn't create a relative increase in.
And so the New York State codes, they're based on some model US codes that go back to the 2000s, even before that, where we had some regional codes that they finally came into the ICCs. These prescriptive code limitations in the codes have been unchanged for 25+ years. So as these buildings and as we as society get more sophisticated and our demands grow, the codes in this regard, this line, the same for units used, has not changed for the better part of 30+ years. So it didn't contemplate back in the day. There weren't million square foot plus buildings, 30 years ago. Now we've got these multi-story 3 million buildings where the code doesn't quite keep up with it. So this is, the performance-based design is our attempt to look at the equivalent risk theory concept that's baked into these codes to say, is this okay? And again, we rely heavily on the results of the full-scale fire testing and put that model.
And so just to jump into that testing now, so is there any indication that it is, because it's obviously a much smaller, even though it is a full scale, it's much smaller in its area, right? Is there any indication in testing or previous data that increase in area would produce a different result, or that, just would you anticipate any sort of different scenarios due to the increase in actual floor area and the propagation of the smoke that could happen in the larger ceiling or anything of that nature?
Meaning with the liquids versus without?
Well, just meaning the smoke, the test that you guys ran here, I can refer to the, I'm talking about exhibit B, the fire and egress modeling, where you showed these real-time snapshots here.
Mm-hmm.
So the question being that if this was over a lot, because this was modeled in a smaller floor area, is that correct?
No, so the fire and smoke modeling, we modeled the geometry of the building.
It is, okay.
Yeah.
Okay.
The geometry difference from the UL fire testing, that large scale lab is 120 feet square.
Okay.
And it has a movable ceiling that's 100 feet square. So, and then we actually brought in the 10X pods
Within that.
and tested within that. And again, that's in line. If you go see a sprinkler that's you all listed, it was tested in that lab. So it really follows to a T, the standard.
And in your past experience, that's true in the sense that what you see in that lab would be representative in a.
Yes, and even with some conservatism built in. So something that's critical to this tenant is they don't go put all the same beaches next to each other. Their methodology is all random based on geometry of can it fit and put it there. So that helps drive efficiency. So you're not going to go find a lot of pods that have nothing but this. And so we do the same thing. You want to find, we're limiting the request to 60 ounces per pod for the liquids. Even if you have a bunch of liquids, they're not going to put them all there, even inherent to their operation, because it's all based on random stuff. So you have an inherent dilution of the fuel commodity that you would expect in a building. But what we tested at UL is nothing but plastics. So where you're actually going to have a mixture that's random of ordinary group 1 through 4 and some group A plastics with the 60 ounces of liquid.
You're not keeping the gas next to the styrofoam.
Right, right. And so, and all of that, but in the testing, we purposely tried to challenge it, so it was nothing but the polystyrene group A plastics. And on the liquids, we purposely put them in a configuration to get them to be involved in the fire very quickly, right? We didn't want to try to game the system to put the liquids up high or try to hide them from ignition locations. We wanted to see if a pool fire could be created and overwhelm the sprinkler system.
And then, so fantastic, so I think really my last question, and just jumps right into it, is, so it sounds like most likely it was, but were chemical systems considered, and why are they not incorporated or needed in this sense, you know?
Yeah, so chemical, or if you're talking about gaseous, kind of.
Any sort of fire extinguishing systems,
Yeah.
or gaseous systems, or there are many other alternatives.
Yeah. So those systems, we did consider them, but very quickly figured that it wasn't viable. One, with gaseous systems in particular, you have to maintain a compartmentalized integrity, right, to hold the gas at a certain concentration for it to do the extinguishment that it's intended to do. You can't practically do that in a large space, right? And then two, even if you could, the amount of fluid that you would have, the gas canisters and whatnot, would be so phenomenally large that you would have to have massive tanks around the site that it quickly becomes impractical to try to address this type of volume with that type of extinguishment system.
And, okay, and then, so I guess actually the last stuff is just, so in the storage racks, or however the pods are contained, are those sprinkled themselves as well?
They aren't. So the floors, the upper floor, 4 stories. So floor 2, 3, and 4 are pretty much the same, with the floor to ceiling height being about 13.5 to 14 feet, if my memory serves me. The topmost floor is open to the roof, so it's got that kind of ridge roof. So it's got a peak ceiling height upwards of 15 or so feet. But no, there are no systems. Those pods move, and they're 8.5 feet tall, so you have about 4 to 5 feet of clearance, and the sprinklers are up at the deck. And it's worth noting that the sprinklers that we have, normally where you can do a smaller sprinkler, a K8 or a K11, that's a physical parameter just based kind of on the size of your system sprinkler. We're doing a K25, so it's really ESFR-like. It's an extended coverage sprinkler that could be spaced for the listing, maximum 196 square feet, so 14 by 14. But we purposely selected that type of sprinkler and then reduced the spacing to say we want suppression that you get out of your typical listed ESFR, early suppression, fast response. But we have that spacing. It's a sprinkler that could be spaced 14 by 14. We're nominally only allowing it to be 10 by 10. So it's spaced like your typical sprinklers that would be good enough for very tall ceiling, high bay rack type of hazards. And we're putting them at 13, 15 feet above 8.5 feet of plumbers.
And, sorry, you're actually, so, well, I have a couple more, sorry. So then, and you talked about the duration being 3 hours, and that's over an area of,
So the design criteria is 9 of those sprinklers operating at 30 PSI. We tested it at 10 and 22 PSI, so there's some safety factor in terms of what the design is contemplated over the good suppression results that we saw in UL. So the 930 is relatively 900 square feet. The duration from that perspective is going to be much more than 3 hours from the purely sprinkler. The systems that we, or the operation and the testing, you see only a few sprinklers operating. So if that's what you would actually expect, you've got safety factor in terms of the number of sprinklers we're including in our design. But even that is not the driving duration for the water supply. That's really coming from the outside fire flow requirement.
I understand fire.
Yeah, so from a sprinkler perspective, if you just have sprinklers go off and you don't have active firefighting, you're gonna have well under 3 hours of duration.
And in the fire testing, what was the time roughly for the activation of those sprinklers?
Question. A lot of those, because they're so close to the ceiling, they're gonna operate in, I'm trying to find the table, Grant, if you can.
Because conceivably a pot could be right on the floor, right? And then.
Yeah, so and depending on where the fire is in the testing, it could be directly into one sprinkler, it could be between two, it could be between four, so we tested all those, but you see sprinklers activate in a range of just a few minutes, within three minutes.
Thank you. That's all.
This that was just dropped here, this is the hard copy of the revised submission, is that correct?
Yes, that's the May 28th.
Okay. We don't have to mark it. Megan?
Yes, thank you. I'll add on to the sprinkler questions since that's what we were just speaking about. So you have redundant loops and with two different sources, tanks and the public water supply. Has that been vetted, the public water supply, that's going to?
But we have 2 tanks. So because of the public water supply, we do have 2 of these 360,000 gallon tanks.
Okay. Yeah. You're going to have a fire safety force, it was described, in the building. Can you tell me a little bit about the fire safety force and their training?
Yeah, so I think that came out of the determination for Syracuse originally, and I think it's carried for other facilities and other board reviews in the state. But basically, it's a trained on-site fire brigade, if you will. I believe it could be some typical tenant employees or associates, but then would have to go through specific training to understand the hazards and the responses. I think there's also one of those personnel that would be designated for that fire safety force that is supposed to man a dedicated fire command center in the building. So that's where some other reporting electronics would be, and for them to kind of monitor those systems, smoke control panels and power line panels and whatnot, to even help in aiding perhaps calling the fire department, dispatching them, or trying to get the fire safety force deployed internally. The specifics of the training, I can't personally go into too many details there, but it would be short of, I think, full-time firefighter type of training. I don't think that's what that is intended to be, but it's also not going to be a group of people who are just trained with fire extinguishers, for example. It's going to be someone
specific. Okay. The exit access distance, the code requires 250 feet max. You're requesting up to 400. What percentage of the employees would be, it mentions in the petition that many of the employees would be within 250 feet. What are we talking about? How many employees would be further than that?
So on the first floor is probably where they would be the furthest from, in excess of 250 feet. And before we keep going there is a code prescription that allows for 400 feet, so we didn't just make up the 400. But we just don't, I think you need a 24-foot clearance from floor to ceiling above to be able to meet those prescriptive requirements. So because we don't meet that, because of the multi-story nature, we're approaching it with the model to look at the building. For the upper stories, I would almost say 100% of the employees up there would be within 250 feet because they're really only normally occupied around the perimeter. Only if somebody who's specially trained to go inside that chain link fenced area, perhaps they would be then further from 250 feet. Unfortunately, I don't think we've done an analysis to say at a given time or a given shift what percentage of the folks would be beyond the 250. We can look into that to see what percentage of the floor areas would be beyond 250 and not moving.
Could you just describe a little bit more to me what the first floor activities or equipment or, is there a clear wide aisle to even if it's hard to
Yeah, so they have what they call kind of dedicated tab. It's kind of, I'm not sure if you've heard of 5S, but it's kind of this industry or industrial, everything has a place, everything has a home, some type of warehousing management approach. And so they've got things for dedicated places, including a lined out taped walkway to where you wouldn't be able to put a pallet load or a pallet or a dolly or a cart or anything like that. But what the tenant calls their deposit, that's the machine that goes in the building. It's miles of conveyance. Sometimes you've got conveyance on elevated platforms, but you'll have prescriptively code compliant from an egress perspective, stairs, or perhaps maybe a ship ladder if it doesn't require normal means of egress. So that's really string about the whole floor, but you do have dedicated egress components. And the egress is not intended to necessarily go through the lands with some sort of lift gate or anything like that. It would be dedicated in that iterative approach with the tenant, the architect, to make sure that the intent of performance-based design is met.
Okay, and the mezzanines are different than the actual stories above.
Yeah, so there's if I just find, or if you help me find a exhibit, a figure in the order, gives a good example of the first floor. Maybe on page 4, it's kind of light to see some of the elevated. Yeah, there you go. Go to figure 2 on page 5. So there are elevated conveyance on the upper floor, but it's not on platforms or anything like that. So there's no elevated levels on floors 2 through 5. All of those elevated levels are largely unoccupied. They're really just there to elevate the conveyance to get it up off the ground floor, so they have more real estate to put this or that here or there. So there's a couple there that are, I think, in red that are indicating visually that they are occupied. So the modeling accounts for some personnel to be up there, and then therefore when we tell them to start moving, they start to egress off those elevated mezzanines, and so those will have normal prescriptively compliant stair systems that will meet the code requirements for these egress. The other locations are largely unoccupied, so it's a current building that they would fall under the platform category, but you kind of get a sense of those will be the predominant elevated levels on that first year.
Thank you. When we are considering the distance to exit egress, it also mentions about visibility, temperature, and toxicity. So I wonder with the increase requested for flammable liquids and plastic plastics, where do we fall on the toxicity?
Yeah, so our experience in these types of facilities, because of the area and the volume that you have, well, let me back up. The modeling that we did and the UL testing was based on 100% UV plastics. that tends to be a much higher heat of release, so heat of combustion, so it's gonna burn hotter faster, produce a bigger fire concern, but it also produces, it's at a higher soot yield. So when we model that, a higher soot yield and how we design fires, which I'll get into in a moment, produces in the model more smoke than you would probably expect in the real world because of that random commodity mixture. It's not gonna all be group A plastics. So, and then you get into the design fires that we have, and even those are somewhat conservative in terms of what we would actually expect based on the fire testing compared to what we modeled. So if I can get you to go, one moment, find the figure. So if you can go to figure 14 on page 44. So that is a graph of some results that we saw from the full scale fire testing. And so that's a heat release or a temperature. So it kind of corresponds to heat release. That's a temperature over time curve. And you see that sharp decline because that represents when the sprinkler is activated in the lab. So we took that information, but then we created design fire scenarios. So if you go down to the next page, figure 15, you kind of see a little bit of a similar approach there. But so to explain those design fires in the real world and in the testing, when sprinklers go off, you pretty immediately see a sharp decline where that sprinkler system starts to control and suppress the fire. We allow in the model that design fire that kind of overlap you see on figure 15. We allow those fires to continue to grow for an additional 30 seconds before we turn it down to start having it get into what's called decay phase. And then we have it based on the figure 14 information, how quickly that goes down to basically zero. Again, that's a temperature time curve to basically get back to ambient temperatures in the lab within 3 minutes. We turn our design fires down to say, you're going to go to 20% of your peak heat release rate and then stay there for the duration of our model. So what that does is the area under the curve more or less starts to say how much heat are you producing and therefore how much smoke are you producing. So there's conservatism there because we allow it to continue to grow when in actuality we start to sharply decline. And the soot yield that the model is actually saying this much smoke and this density of smoke is being produced is more than you would expect because again, we're modeling it all based on a conservative soot yield product on group A plastic, when in actuality you're going to have a random mixture of paper, books, cardboard, various things. It's not all going to have products that are that heat of combustion and that soot yield. So there's the design fires have some conservatism built into it. So when we're comparing its ability, because of the volume, the toxicity, it's just not, it's not enough burning material in those volumes for toxicity to really play a role. So for the CO or other products in combustion, it's just not a concern. I think we have a couple of snippets where we show that, but then because it's such a non-issue, we don't continue to show it. So most of the figures that we're showing are based on visibility because that tends to be from academic literature and whatnot. That tends to be the issue that disorients people. If you don't have visibility, they can't actually start to go backwards, they go into place, then they start to inhale the smoke.
Are there any other smoke mitigation systems or anything in the building?
We do have some systems that are mechanically going to be designed into the building, but we're not reliant on the performance-based design to maintain those typical conditions. So we will have a smoke control system. So from the fire code, it's a section 909 smoke control system. So that will be prevalent throughout the predominant rectangle of the building. We also have similar but again, those are not relied upon to maintain minimal conditions, so we don't turn them on in our model to feedback smoke actively. Those would be systems that really the fire department can use at their discretion when they arrive.
So the flammable combustible liquids are only going to be contained in fabric pods at the maximum quantity
Yeah, 60 ounces. There are other strings attached to our request because we're not trying to extrapolate really beyond the testing parameters. So it's 16.16 maximum container size, maximum 60 on a per pod basis. That comes out to about, if every pod was full to that 60 ounces, it's about 0.052 gallons per square foot. There's some code analysis that we go into what the code otherwise tolerates for other situations. What always jumped out to me is the code would tolerate 2 gallons per square foot in an unsprinklered crude end mercantile building. So from the equivalent risk area, when we're back by the full scale testing, it's basically saying that there's not a substantial amount of liquid in these pods, even if every pod was full of 60 ounces.
And then the non-miscible liquids are further limited.
But because we tested a class 2 miscible, a class 2 non-miscible, we would say you could have non-miscible liquids class 2 as well. So class 2, 3A, and 3B. So if you think about it, 60 ounce in a motor oil, that would be a non-miscible class 3B. The miscible liquids, we tested isopropyl alcohol in 60 ounces. That's a 1D flammable liquid. So you can have miscible 1B to 3B, non-miscible 2 down to 3B.
Okay, and these are only in the fabric pods being the largest, but,
Yeah, so this is a part that we have been asked and we're trying to approach holistically to give the tenant flexibility. These requests in terms of the pod types, Megan, that you're honing in on, they are mutually exclusive. So if the tenant has fabric pods, they could have the FC liquids. If they have the tow pods that are included in the analysis, they would not have FC liquids. We do not currently have testing with the liquids and the tows.
okay. Yes, I was gonna ask what is the percentage of fabric pods compared to the other pods?
It would be 0 and 100. If they bring fabric pods in, the system would be 100% fabric pods. They would not intermingle. Is our understanding.
Okay. So, I had the same question about the water, using water on some of these flammable combustible liquids and that not mixing or perhaps, actually spreading fire. And I was wondering, would there be certain locations in this facility that only those pods would go, but I did read that the pods just get replaced randomly, so like Tetris or whatever, right? Wherever there's a free spot. So I feel like you've answered some of my concern or questions, about that. I saw that there was support from the township, the local fire department, and the code official. The local fire department is volunteer.
I'm not sure. I can.
Okay.
I don't know.
Okay, I wondered about the county emergency services. Have they been invited to the discussion, Orange County?
Yes, we had a meeting with them last year to go through all of this.
What happens when the flammable combustible liquid and they leak? What's happening?
That would be if an item happened to fall out of the pod, it would be just like that. If a leak happens, they're gonna have some spill, they're gonna have an on-site safety emergency management plan, go on an emergency action plan that they would have to enact and go do a spill thing.
I'm gonna call it on my question right now. Thank you. I'm not gonna say I'm completely done, but I will pass the baton.
Okay, Jane?
You mentioned that you're asking for 49,500 gallons of flammable liquids. What's the total now?
For For this, if you take the baseline, double it for being in a sprinkler building, double it again for putting those in flammable, your orange, your red kind of hazmat cabinets. It's per category basis, but it's in the realm of 480 for 1Bs, 480 gallons, maybe 13,200 for some class 2 or 3. So it's a per category basis, so it's not necessarily straightforward, but we're orders of magnitude above the baseline.
Very hard to see this plan. Can you tell me what the basic overall footprint size is of the building?
Yeah, 652,000 for the first floor, and then the elevated floors are 606,000.
Okay. What's that in footprint? I'm thinking, it's going somewhere with the travel distance question, so.
Yeah, so it's probably 1,500 by 550.
That looks about right, yeah. And right now, there's 8 egress stairs, right? Is that what I'm seeing from this?
I believe so, around the perimeter.
Visibility analysis. So when you talk about, you're asking for the maximum travel distance of 400 feet, where is that coming from?
So the code basis for that is if you meet the prescriptive requirements of section 1017.2 for F1 and S1.
I mean, where's it coming? Like, there's no.
It's
plans
just,
that I can see. Typically when.
I got you, yeah.
You do the travel distance plan, so
yeah.
where in this footprint are you at that maximum 400?
So everywhere, every single point in that building, you would be able to get to at least a single exit. And I'm not sure this is going to answer your question, so exactly different. Every single point in that building, you'd be able to get to at least a single exit within 400 feet. The percentage, and maybe this connects maybe to one of your questions of what percentage of the floor plate exceeds 250, but not more than 4. That's going to predominantly be in your middle, your middle.
Just in the middle section here?
And we haven't sliced it up that way to say how much, percentage of the floor plate would be at that 400, but.
Yeah, it would be interesting to see, because if the building is 550 feet in the one direction, and if you're stuck in the middle.
Yeah, 225 to the perimeter, and then based on the distance.
Right, so I don't know, but my question is, do you really ever hit that maximum 400 anywhere in the footprint? Because if you take 250, 550 and cut it in half, it's obviously not 400.
Well, yeah, and the spacing of the stair towers is going to be more than 100 feet or so apart. On the first floor level, that's another prevents requirement that you have to space the words maximum.
So it may be only on the first floor, because the first floor is the larger footprint.
Yeah. There are going to be some spaces on the upper stories that exceed 250. So, but we can get the architectural plans, the life safety egress plans that kind of show those egress triangles, if you will.
Mm-hmm.
But I don't think we've done an analysis to say what percentage of the floor plate exceeds 250. But it is going to conceptually be in that middle kind of the dome.
Right, so there may be parts, what I'm saying is you may not actually hit that 400 threshold that you're usually in the maximum code.
Correct.
Especially, how do you hit 400? Because that's not working with the math.
Yeah, as a maximum threshold. Instead of saying we need 371, it's the code has 400. We don't comply with prescriptively with that. So we're trying to comply with it, still do 400, but we're trying to comply with it.
But if you could, obviously be less than.
But I like the questions, and now we're going to go back and get that answer and see.
Yeah.
Maybe it's
Well, in order to
we
get
have
the
to say
permit,
it's only
you typically,
50%.
yeah, you typically need to have, show your maximum travel distance on the plan. So I didn't see it on the plan. That's all I have.
Okay, not last but not least, but we're gonna go to Mark. Mark, I don't know.
Yep. All right, can you hear me all right?
Okay, all right. Now, the question is, can we hear Mark? Well enough. All right, let me put my. All right, Mark, you want to?
Yep, so can you hear me all right? I hear feedback when you cranked it.
You hear him through there?
Yes.
Okay. All right, try it again.
Okay, can you hear me all right now?
Yeah.
Yeah, just.
Okay, great. So thank you for your
Hold
presentation.
on 1 second, Mark.
You trying to figure out?
you turn that up?
I can try. As high as it will go without going to the speakers here.
That's it?
Yeah.
All right, let's try it again, Mark.
Okay, are we ready?
That's the best we're gonna get with it. Good? All right, go ahead.
Okay, so I just want to thank the presenters for their presentation and the comprehensive material you provided. There's a lot of information to try to digest here, so pardon me if my questions were addressed in the material provided or if I misunderstood anything that you presented. But the first thing, Mr. Chairman, is that I did see that there was a statement in here regarding the code enforcement approval, but I didn't see a code enforcement questionnaire. So just want to make sure if we have the code enforcement official on, that we get that on the record. Second issue, I guess my first question is that in the Phillips Little LLP cover letter dated November 19th, 2024, on page 4 and in Exhibit D, he lists several locations where New York State has granted similar variance requests for departures from the New York State Building Code exit travel distance and construction fire resistive ratings for type 1A construction. Did they also request variances from the MAQ? And if not, why not?
We only have one site in the state that requested the variance from the MAQ. The reason for that is just the timing of the tenant bringing that business desire, bringing it up. Historically, it wasn't part of these facilities, and it's a fairly recent business endeavor for them.
In that site that requested it, was that granted?
It was just recently the Florida, New York location.
Okay, and it's my understanding that one of the reasons you're proposing to use the performance-based design versus conventional method to protect the structural steel members is because the spray-on fireproofing becomes friable and presents a hazard to your robots. Is that correct?
Yes, the technical issue there is that it's not a perfect system. It can flake and degrade over time. With it being a multi-story, and we can't necessarily say that there won't be vibrations and won't have to degrade with that. It's just a normal operation. They did look at that, and it is, once you do get that flaking and whatnot and fall on the floor, there's a really tight tolerance in the construction of these concrete floors. So if you start to put obstacles or other things in the way, it can really mess with the robotic and the optics of how those things drive around the floor.
Right. So my question is then, looking at other conventional methods such as concrete columns or using structural steel protected by a UL listed rated system around the steel, why didn't we go that route?
I think that's more towards just the construction schedule and cost impact, but also kind of the loss. They get pretty tight with their calculations of what the building affords them from a cube or storage capacity perspective. And so if you start to wrap all these columns, you start to put some sort of drop ceiling that's a fire resistant ceiling, that could push your ceilings to have to be even taller, right? The floors have to be even taller, so then you get upwards of a even taller facility still. So I think it just has a little bit of a domino effect on feasibility from a cost and schedule impact.
Okay, thank you.
And if I could just jump in real quick, sorry to interrupt, Mark. On the code enforcement official point, he was unable to join us today, but we did submit a letter of support from him for the variance application.
Okay, is that in our packet? Because I didn't see one.
That came via email from Barbara last week.
Yeah, it was part of the supplemental submission or.
Okay,
revised.
as long as we have it. That's fine, as long as we have it on record. That's all I'm looking for.
Yeah.
Okay. And I believe I understand, your discussions about sprinkler redundancies, including fire pumps, municipal water supports, storage tanks, etc., underground loop, main, above ground loop. But I didn't see any sprinkler schematic in our package, so I'm wondering if someone can explain how the redundancy works for feeding the floor isolation control valves. And also if the floor sprinkler system is a looped system.
Yeah, so the systems themselves are looped and gridded. They get fed from a kind of a more typical single fed riser. The riser manifold that each sprinkler is supplied from both loops. So the interior loop on the first floor that's above ground, that goes and feeds these these vertical and horizontal sprinkler system manifolds. But so too do lead-ins from the underground loop tie into that same infrastructure. That's a good question, Mark, because so this performance-based design, the report that's in front of you all, it really complements the building permit package. Part of that building permit package is a 20+ page criteria set of documents that I think we reference, being the fire protection criteria documents. Those go into a little bit more constructability, engineering specifications. Those do have some schematics in terms of what the risers look like, the standpipes and the stairs, the typical structural based sprinkler layout respective to the 100 square foot nominal spacing we were talking about earlier. So those schematics are available. They're just more design, engineering design specifications that are in the architectural engineering drawing package.
Okay, but did I hear you right that you said it's just one riser per floor isolation control valve, or is there multiple risers fed from the? I understand the dual loops. I'm just trying to find out, do we have a single point of failure with one riser?
A given system does have just one riser. So once you hit a riser manifold where you may stack on 4 or 5 sprinkler systems, sprinkler system risers, once you go through a riser control valve and you get into a specific system, which is laid out prescriptively per NFPA 13. So a given system is not going to be more than approximately 40,000 square foot of coverage. Once you get to that level of the system, it is more of a traditional system. So it's everything upstream of that is where the redundancy is at.
Okay, so there's multiple risers feeding the 40,000 square foot since our footprints are 606.
Yeah, given
606,000.
sprinkler system zone is 40,000 square feet, so you're going to have
Right.
18 to 20 sprinkler system zones on a given floor. So if something goes off, if you need to shut down one system, you're only taking out about 40,000 square feet to do whatever sort of normal, inspection and maintenance on that system.
Right. Yeah, that's what I was looking for. Somehow to reduce the risk of one riser failures. Okay, thank you. I know we've talked a lot about MAQs, and I think we're struggling with understanding the MAQ numbers. So first off, help me understand how material moves from floor 2 through 5 to grade level. Is that in a shaft? Is it in an open shaft, or is it a rated shaft? How do you move material from floor down to grade?
Yeah, great question. So the performance-based design and the type 1A construction is really predominantly looking at the floor ceiling assemblies. There are parts of the building that are intended to be prescriptively compliant. One of those are those material handling shafts. So those are 2-hour rated, prescriptively designed and constructed shafts that are going to be, kind of 4 or 5 of those around the perimeter. Those are going to be, normally unoccupied, really there to connect the stories from a conveyance perspective. So you have some areas where they call them VRCs, so it's a vertical reciprocating conveyor. So those are a step different. It's not even a freight elevator. People can't ride on them. All the controls are outside. You push something in, you come out, you hit a button, it goes up or down wherever you're sending it. And then you have some spiral conveyance to take totes or other individual products up to or down to floors. But you do have 2-hour rated, more intended to be prescriptively compliant material handling shafts connecting the 5 stories.
Okay, so do you view each floor to be its own fire
You could get into that if you're talking about from a fire flow perspective, but I think we actually think of the fire area as a whole building, so, we do have obviously rated construction separating, with the type 1A construction, but the whole building, we don't try to dice it up into 5 different fire areas from a prescriptive code definition perspective.
Okay, so your 49,500 gallon restriction for aggregate you're talking about, that's for all floors then? It's not per floor plate?
The entire facility, yes.
Okay,
So that would be inclusive of inbound products, anything inside the envelope of the building, everything on the roof is part of that 49.5.
okay, thank you on that one.
So that, to just take that as separate, that necessarily means that you can't reasonably have the pods full of 60 ounces, right? Because if the storage fields are full, you can't bring anything into the building. So there's just the operation of filling it up, fulfilling orders that are coming in, bringing in new product, shipping out product that are, you're going to have some inherent buffers in there because you can't operate if the storage pods are 100% full.
Okay, thank you. Let's see, next question I had was, I understand your Exhibit B, which is your PBD, page 7, indicates modeling was not included in the combined hazard of flammable and combustibles with the Class A plastics. Is that correct?
I'm sorry, say that again, sir. You said page 7 of the exhibit?
Correct. Well, that's page 7 of the version I have.
Let me just make one point for the record. When I referenced Exhibit B, that was the PDBA in our original filing. For everything that we've been talking about now in the PDBA, that is within the main filing. It doesn't have an exhibit letter because it was the only exhibit in the May 28th filing. So you might be looking at page 7 of the original filing. You can pull that up.
Mark, can you speak to a section?
So let me go back to maybe rephrasing it to say on the original submission, Exhibit B, page 7 should be. I'll get you a section over here in a minute.
Is it 211 pod types?
211. Yep, thank you. 2.1.1.
Okay.
Pod types. I read that to say that your testing was done and with Group A plastics without flammable and combustibles, correct?
Yeah. So this is there are multiple pod types contemplated in the report, but the FC liquids are only compatible with those first pod types, what we call the yellow fabric H pods. We did test the liquids in those. We have not tested in the tote, the open top container type of pods that are referred to as DTP or HDTP. So liquids are only in the yellow fabric pods.
Correct. So I guess I don't know if it's a question or my thought is that I would expect that the flammables with the combustible plastic totes, Group A plastics, would create a fire hazard, and that hasn't been tested. So how do we control the end user from putting flammables and combustibles in those plastic totes?
It would be a permitting limitation to say if you bring totes in here, you are not approved to have FC liquids. But if you bring the yellow fabric pods, you could put the FC liquids in the yellow fabric pods. Our understanding is that it's all or nothing. They're not going to mix and match and say this floor is totes, this floor is the yellow fabric ones.
Okay.
It's going to be the whole facility gets the same pod type. And so if they elect to go with the tote version, they would not then have approval to bring in the FC liquids.
And the prior DOS approvals have had explicitly stated in the findings and conclusion of law that this approval is based upon the PDBA and the conditions that's described in the PDBA. So if the end user was to be doing something inconsistent with what's in the PDBA, that's not covered by the DOS approval.
Great, thank you. And I did not understand that there were different, or it was going to be only one. So I was thinking you might have one area with the plastics and one with the fabrics. So thank you for the clarification. And the next question is, in your PBD Appendix 2.0, it defines the ceiling heights from 13 feet 9 inches up to 27 feet 7 inches. But Table 5 states the visibility is maintained above 33 feet. So can you explain how you get visibility height greater than the actual ceiling heights of the structure?
So the visibility is a horizontal measurement, so we're looking for, you can see horizontally 33 feet or 10 meters. That the ceiling heights are obviously vertical.
Yes, thank you. I missed that.
And we're evaluating that threshold at an elevation of 6 feet above the floor. So that's, and not everybody's 6 feet tall, but that's where the industry says we evaluate 6 feet above the floor. Not many people are taller than 6 feet, I should say that.
And the last question I have is on the PBD section 3.3.3 talks about administrative controls, and then it references you back to the Appendix C, which was to me mainly a notification and tracking system for impairments. My thoughts are there probably should be stricter administrative controls that would be required if the sprinkler system is impaired and you have this excess of flammable and combustible liquids. I'm not, maybe that will be part of our conditions. So what are your thoughts on that?
So the administrative controls that are being referred to in section 333 are maybe more aptly referred to as operational controls. What we're talking about there are, we don't want to rely on the human element 100% to say, don't put more than 60 ounces in a pod. It's talking about the tenant's system, software engineering, to make sure that their warehouse management system won't exceed, reasonably won't exceed the requested 49,500 in the whole building. You won't have 1As. If something does get there, they can identify and quickly get it out, right? Because no system, we're not reporting perfection. But that is more of the operational controls, more on the system engineering, software engineering of the warehouse management system to make sure that these conditions that are being put in place, backed by full-scale testing, that we're not collectively relying on the human element to say, abide by these, that the system within the facility will help the tenant maintain those proper conditions. On the idea of a system impairment, they do have an impairment plan. That's just part of their normal kind of warehouse management of if the system breaks down, whether it's fire, sprinkler, fire alarm, or any other mechanical system, they have an impairment plan to what to do and how to get that building, that system back up and running. And part of that is connected to the fire safety force of what happens is, I would suspect that fire safety force is going to have some sort of quasi fire watch in that area if the system does go down for any sort of planned or unplanned maintenance event. But that is part of their normal protocols.
Okay. Thank you. That's all I have, Mr. Chairman.
That's it, Mark?
Yes, sir.
Okay, thank you. I understand the fire protein issue and the liquids. I'm a little bit hung up on the chemicals. So you said that the driving force of that was the ceiling height. Is that correct?
Correct, because we don't have 24 feet, that's what prescriptively is called for. We don't have that, so we technically don't have a path prescriptively to get beyond 250 feet.
And I know that Jane got into some diagrams as to help us better understand the travel distance issue. But let me ask it this way. Would we safe to say that no matter how many additional exits around the perimeter of the building you put,
You probably couldn't get within
you're
250.
still not going to get to 200?
And it would get to that point of no return, kind of you can't have the entire perimeter of the stair exits, right? It's just not a practical thing. So it really is, if you force it to be no greater than 250, that footprint shrinks. And now that you have the business liability of saying they need the building to have so much throughput, it's got to be ordering, fulfilling so many orders, so many packages leaving the building daily, to where it doesn't make economic sense for them to build a building that small.
And the center staircase would make sense with the upgrade.
It doesn't, and that part's cordoned off anyways. You wouldn't want people going into that, fenced off area to go get to a center stair.
Okay, that's all I had. So what we'll do at this point is,
Can I ask one more question?
Oh, I'm sorry.
I'm sorry,
I apologize.
I found when I told you. What about lithium ion battery storage? What is the situation like? Are there, because we have other concerns, right, with lithium ion batteries? And then a follow-up to that is the robots. What do they run on?
Lithium ion.
Okay.
So it's a great question, and not to be funny or anything, but it is a hot topic in our industry over the last several years. But I'll say all of the products that are in here are consumer products. The technology that we're talking about has been in buildings across the country for more than a decade. We have had some fun. We were able to burn a drive unit. They are not easy to ignite. The batteries take a long time to get involved and start popping, like you may see on YouTube. By the time that would actually happen, sprinkler systems would have well already been activated. So we have analyzed this from a kind of engineering materials analysis type of thing, a fuel hazard perspective, and we think it's a very likely ignition source, but not an overall fuel driving issue. So the pod itself, especially with what we tested for plastics, is more of a driving fire hazard once you actually get involved. But you have things that, whether it's a consumer product like watches that have lithium, the disc batteries, or power tools, or the drive unit itself, they have battery management systems on board that if it starts going into a thermal runaway event, that battery management system is going to shut it down. But then it becomes a likely ignition scenario that doesn't necessarily add to the overarching fuel package that we tested. The other thing on the being able to burn the drive unit itself, one of our, we did have fun doing it well, being able to burn these things. That there's a fire retardant plastic on it, thermoplastic, where it really struggles to maintain combustion. It really just drips and quickly hardens on the floor. The way we had to ignite it, we put it up on some cinder blocks and put heptane fans underneath it. So it really wasn't even a realistic. Otherwise, to put a normal industry standard igniter next to it, I don't think it would ever go. It would take way too long, and your igniter in a lab perspective would run out before you actually get the robot itself to sustain combustion. So putting heptane fans under it on cinder blocks, you might have that in the building. So they're quite safe, and I think they're that close of industry in the field experience where we recognize that these consumer products are there, they have lithium ion batteries, but it's something like an ignition source. We're not talking about bulk storage of it just came from the battery manufacturer. We've got pallet after pallet of nothing but lithium ion batteries. These are just smaller batteries, small kilowatt battery energy capacity in your typical iPad, computers, power tool type of consumer products.
Okay, and then the robots themselves, where do they get charged? Where?
In the field, so at various column spacings, and I'm not exactly sure what the spacing is, but they're around the column, there's going to be a cluster. Instead of pods, it's going to be chargers. So when they get to a certain state of charge, let's say 40%, they're going to stop doing operations and then going to charge for some duration to get back up to 80 or so percent to get back and be on call for those operations.
It's just like a Roomba robot on the part.
So the whole robot, I'm sorry. So the whole robot goes to that location, not just the battery.
The battery, yeah, the robot is, the footprint of the pod is 3 feet by 3 feet. The robot is effectively that size, maybe a little bit smaller. It drives underneath the pod. A little piston rises up to carry the load. And, those pods can get fairly heavy, several hundred pounds. So it's a fairly robust, mostly metal, steel, aluminum. It's got 2 onboard lithium-ion batteries inside the casing. And then on the top, you've got the electronics and the optics and all that stuff. But the outer shell is that fire retardant kind of plastic. But then other than that, the whole bottom is a steel composite type of alloy.
Yeah, I'm sorry.
No, that's okay.
You
Yeah,
can't
it's
see
just,
the
it
video?
seems, when a charging station that's in the, midst of things, charging of something that's wet or is wet, can be a problem too. So again, I respect the sprinklers, but, okay, so thermoplastic around it to protect it from,
They're not easily detectable. Those are the robot drives themselves.
Okay.
Yeah, no, I think, I think it might be beneficial to know as well that it seems like effectively the building is built almost like a high-rise, right? Because you have smoke-proof enclosure, you have fire command center, like, you guys have also, there's other protection elements that you haven't mentioned here that you can incorporate as well, right?
Correct, but the top of the floor is 74%.
So it is a high.
We're not more than 75%.
Okay, so, we're done with the questions from the board members, so at this point, what we're gonna do is going to open it up to the public. So is there anyone here live in the audience, who would like to speak to this application? Hearing anybody? We'll go to, anybody attending remotely who would like to speak, regarding this application. Okay. So at this point, what we're going to do is go into deliberations. If you don't mind, we're going to go up forever. If you don't mind, if you could just step out and then we'll call you back out.
Thank you.
Okay, we're back on record. Megan, you have.
Yes, Mr. Chairman,
Oh,
in
you
regard
gotta take
to
the whole choice
petition
of
2024-0596, the petition
And
of
this thing,
NL
it's
Properties
DMI.
LLC.
part of
I make the following motion. One, that the Board of Review find and determine that the issuance of a variance in petition 2024-0596 will not have a significant environmental impact and will not have a significant adverse effect on any significant fish or wildlife habitat, scenic resource of statewide significance, important agricultural land, or area included in an approved local waterfront revitalization program. And two, that the Department of State be authorized to sign and deliver on behalf of the Board of Review, the Department of State, A, the State Environmental Quality Review Act short environmental assessment form indicating that, quote, no or small impact may occur, unquote, in response to each question in part 2 of the form and determining in part 3 of the form that the proposed action will not result in any significant adverse environmental impacts. So moved, Mr. Chairman.
Okay, so we have a motion. Do I have a second?
I'll second.
Jane, second. Before we vote, do you understand the motion?
Yeah, I just for purposes of the record, there already has been,
Once a month.
for purposes of the record, there already has been a coordinated seeker review done by the town, which included the Department of State. So technically, this board is bound by that determination, which was also a negative declaration, but I'm going to pursue the review procedures.
Thank you. All right, so we'll vote individually. Mark?
Aye.
Jane?
Aye.
Meg?
Aye.
Vicky? Aye. I also vote aye. That motion carried. So we'll move on to the motion regarding the petition. Megan, do you have a motion?
Thank you, Mr. Chairman. With respect to the petition of NL Properties number 600 LLC, petition number 2024-0596, the petition pertains to variances in connection with the proposed development of a new e-commerce storage and distribution center for consumer products, occupancy group S1, moderate hazard storage with a footprint of approximately 652,060 square feet, 5 stories in height, for a total area of approximately 3,232,740 square feet, construction type 1A, fire resistant, and located at 22 McBride Road, Town of Wayanda, County of Orange, State of New York. The petitioner is seeking relief from 19 NYCRR Part 1221, the Building Code of New York State, Section 602.1 and Table 601, which states buildings and structures erected or to be erected, altered or extended in height or area shall be classified in one of the 5 construction types defined in Section 602.2 through 602.5. The building elements shall have a fire resistance rating not less than that specified in Table 601. An exterior wall shall have a fire resistance rating not less than that specified in Table 602. Where required to have a fire resistance rating by Table 601, building elements shall comply with the applicable provisions of Section 703.2. The protection of openings, ducts, and air transfer openings in building elements shall not be required unless required by other provisions of this code. The petitioner is seeking relief to allow the use of an alternate method of fireproofing steel frame. 19 NYCRR Part 1221, 2020 Building Code of New York State, Section 1017.2 and Table 1017.2, and 19 NYCRR Part 1225, 2020 Fire Code of New York State, Section 1017.2 and Table 1017.2. Exit access, travel distance shall not exceed the values given in Table 1017.2. Table 1017.2 provides a required exit access travel distance for an S1 occupancy with a sprinkler system to be a maximum of 250 feet. The petitioner requests relief from an exit access travel distance of 250 feet maximum to be 400 feet. 19 NYCRR Part 1225, the Fire Code of New York State, Section 5003.1.1, maximum allowable quantity per controlled area, which states the maximum allowable quantity per controlled area shall be as specified in tables 5003.1.11 through 5003.1.14. The petitioner is seeking relief to allow an increase of maximum allowable quantities, MAQs, for flammable and combustible liquids. The board makes the following findings. 1. Subject petition pertains to construction and operation of an e-commerce storage and distribution facility, the facility. Variances for exit access, travel distance, and fire rating were previously issued for facilities based on higher performance-based design alternative, parentheses, EBDA, in 55 other jurisdictions, including New York State. Most recently, in the town of Niagara, petition number 2022-0042, Exhibit B, and petition 2025-0324, Town of Florida, County of Montgomery. 2. The current proposed application also requests relief from the maximum allowable quantities for flammable and combustible liquids, in addition to exit access, travel distance, and fire resistance rating. 3. The facility will be dedicated primarily to the storage and distribution of class 1 through 4 and prepaid plastic commodities, and will contain certain consumer goods that are classified as flammable or combustible liquids, parentheses FC liquids. 4. The facility will have a design capacity for approximately 6,000 to 7,000 people. However, the tenant expects to have no more than 1,080 people in the facility. 5. The first floor will primarily facilitate material handling and sorting equipment. On the top 4 floors, most of the footprint will be occupied by the confidential tenant's semi-automated storage system, which consists of storage units known as pods and low-profile autonomous robots. 6. The storage pods and robots will occupy most of the footprint and will be contained within a storage field approximately 464,000 square feet in size. Employees will be located around the perimeter of each floor, awaiting deliveries from the robots. The area containing the robots and storage pods will be physically separated from the employees by a fence, and only limited personnel will be allowed inside the fence as necessary for maintenance and repairs. 7. The size and layout of the facility necessary for its operations, relying on large open door plates, requires exit access travel distances up to 400 feet. The performance-based design analysis, EBDA-Exhibit B, demonstrates that the intent of the uniform code will be met by the proposed design and construction following recognized engineering guidelines and principles. The applicant's fire protection engineer has identified that the design solution for travel distance will maintain an appropriate egress time for occupants to safely exit the facility before smoke becomes an impediment to egress by maintaining the smoke layer at an appropriate height above each floor level. 9, the fire protection engineer performed an analysis using computer fire and egress modeling to evaluate the potential impact of certain fire scenarios to occupants exiting the building. Building layout and exiting arrangements are based on the results of this analysis to ensure arrangement that allows occupants to exit. 10. In most areas of the facility, most occupants on the above grade levels are restricted to an area around the perimeter of the floor that is very close to one of the rated exit stair enclosures and well within 250 feet of travel distance from exit. Certain individuals in the perimeter of the floor and specially trained individuals that are permitted within the storage field may be more than 250 feet up an exit while in the storage field. These specially trained individuals are extremely familiar with the environment in which they work and will be promptly notified of any alarm. 11. No members of the general public will be allowed in the facility. The tenant maintains and enforces a detailed safety program to ensure employees are properly prepared for emergency situations. 12. The PBDA documents that mechanical smoke exhaust is not necessary to ensure tenable conditions for egress at the facility, and that extended coverage A25.2 sprinklers also eliminate the requirement for smoke and heat removal under the uniform code. The fire protection engineer has determined that the travel distance of up to 400 feet maintains conditions for occupants to exit the facility. 13, for the facility to be of unlimited area, Table 506.2 of the building code requires that an S1 facility meet Type 1A construction requirements. The intent of the facility is to have a building that meets the performance requirements of Type 1A construction and alternative methods as described in the PBA. 14, estimates place the cost of complying with the fire resistance rating requirements contained in Section 703 and 704 in excess of $80 million, and installation of these requirements could add up to 6 to 8 months to construction time. If the structural steel has to be fireproof using one of the traditional approaches, there is significant doubt the building can be delivered in time to meet the tenant's projected schedule, and the impacts to cost and schedule will make the project unviable. 15. In addition, any cementitious spray applied fireproofing will begin to come off over time, given the vibration which will be present in the facility, and would accumulate on the floors, damaging the autonomous robots which are essential to the operations of the facility, which would make the project unfeasible. 16, as an alternative, 3 significant improvements to building fire protection systems are proposed that would together achieve the performance requirements of Type 1A construction. A, performance. The sprinkler system will be designed to provide A, adequate protection to ensure the structure of the facility does not reach the critical temperature, and B, superior protection by providing a much higher discharge density than required for the hazard and utilizing most sprinklers to achieve suppression of results. B, reliability/redundancy. The proposed design alternative depends on the performance of the sprinkler system to achieve performance objectives associated with Type 1A construction. As such, the reliability of these systems will increase above and beyond what is normally required by providing additional safeguards and redundancies in the sprinkler system, water supply, and distribution systems. The facility will be provided with 2 independent water sources, each with its own fire pump and water storage tanks. The reliability will be further improved by the installation of 2 separate fire loops to supply the sprinkler systems. One loop will be installed underground outside the building, and the second loop will be installed inside. Each loop will be redundantly fed with separate connections to each source of water. C, duration. The duration of the water supply will be increased to match the largest fire resistance rate required by Type 1A construction. the secondary water source, i.e. its tank, will be sized to provide the required sprinkler system and for a duration of not less than 3 hours, including hose stream of water to the building fire sprinkler system. 17. The proposed system is designed to quickly suppress a fire so that the structure will not be threatened. The proposed alternative design will provide an equal, if not greater, level of safety than would be provided in the building if the building were constructed according to the prescriptive uniform code requirement. 18. The PVDA also addresses the storage of FC liquids and their subsequent maximum allowable quantities, and requires limitations on container size and the density of FC liquids in closed containers distributed throughout the pods and storage field, and states that the alternative sprinkler system will ensure effective fire suppression. 19, the local code and fire code official has been contacted in this matter and do not object to the granting of the variance under Chapter 12.5. In accordance with the above findings, the proposed variances will not substantially adversely affect proposed provisions for health, safety, and security. Strict compliance with the code would entail practical difficulties, unnecessary hardship, or would otherwise be unwarranted, because such would be unnecessary in light of alternatives which, without a loss in the level of safety, achieve the intended objective of the code. Wherefore, it is determined that the application for a variance from 19 NYCRR Part 1221, Section 602.1, Table 601, Section 1017.2, and Table 1017.2, and 19 NYCRR Part 1225, Section 1017.2, and Table 1017.2, and Section 5003.1.1 be granted with the following conditions.
May I just make one paperwork related point? I believe in paragraph 8, you referenced exhibit B to the PVDA. I just want to make sure that we're referencing the PVDA that's in the 28 plan. That's the updated one. Exhibit B was the original note on the PVDA. So in paragraph 8, we've got a couple of exhibit B that we say the May 28, 2021.
Okay, yeah. So I will reread item 8.
Thank you.
Yeah. We did not receive the May version, so until today.
Yeah, so you received it, this was just a hard copy.
No, we got a hard copy. We received it via email.
Okay.
That's okay with us. Yeah.
I'm going to reread this. This one is from September. Okay. I'm going to reread item 8.
Yeah, I was thinking about this.
You want to go off the record?
We just go over a second.
Thank you. It can be a finding even if you don't.
Well, it could be. Yeah. Yeah. All right, we're gonna go back on. We're gonna reread that.
Okay, I'm going to reread item finding number 8. The performance-based design analysis, PDDA, exhibit B, issued September 2024, and its update from May of 2025, demonstrates that the intent of the uniform code will be met by the proposed design and construction following recognized engineering guidelines and principles. The applicant's fire protection engineer has identified that the design solution for travel distance will maintain an appropriate egress time for occupants to safely exit the facility before smoke becomes an impediment to egress by maintaining the smoke layer at an appropriate height above each floor level.
so now we're gonna go back
Back to the determination
back to the
under the condition.
conditions. Okay.
Okay, so we were at the determination, of the code section, be granted with the following conditions. Number one, all conditions identified below shall be implemented as shown and described in the petition and listed in the findings of fact above. Two, the facility will use extended coverage of K25.2 sprinklers as described in the petition with a response time index below 50 meter seconds to the power of 1/2, as well as a listing as both a control mode density area and control mode special application sprinklers. Coverage shall satisfy coverage requirements of Class A plastic and as described in the PDA. 3, the facility will utilize 2 independent water sources, each with its own pump. 4, separate fire loops to supply the sprinkler system and storage systems will be provided. One loop will be installed underground outside the facility, and the second will be installed inside the facility. Each loop will be redundantly fed with separate connections to the water source. 5, the facility's water sources will be sized to provide 3 hours of water to the facility fire sprinkler systems and standby systems. 6, all fire sprinkler control valves shall be locked open and electronically supervised. 7, a fire apparatus access road shall be provided around the facility with aerial access from one side. The design of the fire access road is in strict conformance with all 2020 fire code and New York State requirements. 8, all rated stairway enclosures shall meet the requirements regarding roof access and doors as contained in the uniform code. All other stairwell issues will satisfy the uniform code. 9, if required by the uniform code or at the discretion of the local code official, a smoke control system designed in accordance with NFPA 92.2 based on a reasonable expected fire scenario or a manual smoke and heat removal system shall be installed. Controls of either system shall be located in a dedicated room for town of Waylayanda Fire Company use that is not a fire pump room. 10, a linear wire heat detection system for complete coverage on all floors shall be installed throughout the facility. 11, a smoke-proof enclosure for all stairs for the second, third, fourth, and fifth stories shall be provided pursuant to sections 909.20, 1023.11, and 909.63 of the Uniform Code. Stair towers shall have positive pressure systems. 12, the fire alarm station display shall be located within the same room as the smoke control or manual smoke and heat removal system controls. This condition shall be satisfied only if the smoke control or a manual smoke and heat removal system is required by the local code official. 13, the fire command center shall be designed and constructed in accordance with the uniform code, and the applicant shall coordinate with the town of Waylayanda Fire Company regarding the fire location of the fire command center, which shall be located within a room that has direct exterior access and separated from the rest of the building and equipped with a fire alarm workstation and visual displays. 14, a trained fire safety force, parentheses, SSF, in parentheses, shall be provided with members on site and at all times while the building is in operation and shall be trained from an entity accredited by the New York State Office of Fire Prevention and Control or equivalent. 15, a fire command center shall be staffed at all times with at least one FSF member with knowledge, skills, and abilities relating to fire protection, equipment, fire prevention, safety, and fire extinguisher systems, who shall have duties including but not limited to the following: A, locate and identify the fire area; B, provide fire suppression of incipient fires; C, perform fire watch over areas when a fire protection system is impaired or out of service for maintenance; D, maintain direct radio communications with the town of Waylayanda 911 system for incident coordination and responding fire personnel; and E, maintain a two-way radio communication with on-duty facility managers and coordinate the accountability of evacuation in the event of an evacuation or fire. 16, A fire safety plan shall be prepared by the owner and provided to the town of Wayway on the fire company for the facility. The fire safety plan shall be updated on an annual basis or sooner as components of the fire safety plan may change. Such fire safety plans must be reviewed by the town and the town of Wayway on the fire company for the facility prior to the issuance of the certificate of occupancy. 17, the applicant shall assist the town of Wayway on the fire company with preparing a fire department response plan. This response plan should include the town of Wayway on the fire company with all floor plans. Such fire department response plan must be reviewed and approved by the town and the town of Wayway on the fire company for the facility prior to issuance of the certificate of occupancy. 18, any certificate of occupancy issued by the town for the facility shall provide that continued use and occupancy of the facility shall be conditional on continued compliance with all applicable provisions of the uniform code as verified by this decision. In addition to continued compliance with all decisions, any change, including a change from the S1 occupancy described in the PDPA, may negate this variance or require additional protections. 19, battery storage and use shall be in strict compliance with NFPA 55 and the International Fire Code. 20, FC liquids shall be limited to quantities and type as described in the petition and not to exceed 49,500 gallons total in the facility. 21, only the fabric style pods can be used in the facilities if FC liquids are stored. 22, the fire safety / impairment plan shall include a requirement for immediate fire watch upon sprinkler zone impairment. This decision is limited to the specific building and application before it, as contained within the petition, and should not be interpreted to give implied approval of any general plans or specifications presented in support of this application. So moved, Mr. Chairman.
Thanks. Okay, we have a motion, we have a second. Second by Shaheen. We're going to vote individually. Before we do, you have any questions? No. Okay. So, we'll vote, Mark?
Aye.
Vote aye. Jane? Aye. Megan?
Aye.
Shaheen? Aye. And I also vote aye. Motion carried. Parents?
Thank you very much.
We're all correct. Barbara? Okay, next petition is petition number 2025-0577. Petitioner is Fraser Field LLC. The petition pertains to a variance to allow construction of an ambulance service center with sleeping rooms, occupancy groups, low hazard, storage, and R3. 25B. Possible 2 stories and height, 3,600 square feet in area, and located at Fraser Road, Town of Thompson, County of Sullivan, New York State. The petitioner is seeking relief from 19 NYCRR, Part 1221, the Code of New York State, Section 903.2.1, I'm sorry, 903.2.8.1. Group R3 and 19 NYCRR Part 1225 Fire Code of New York State, Section 903.2.8.1, Group R, which states an automatic sprinkler system shall be automatic sprinkler system installed in accordance with Section 903.3.1.3 shall be permitted in Group R occupancies. Petitioner is seeking relief to allow a residential occupancy without sprinklers. Okay, someone here to present the case?
Good afternoon. My name is Joel Cohn. With me, I have Judith Fike, who's the expert solvent coordinator, and also on the Town of Thompson, Code Enforcement James Brown. I would like to begin by introducing Mr. Pike so that he can explain what Chancellor Solar is and what it does, and then we'll go into the details of the building.
Okay.
Mr. Pike? You heard it? Yeah?
Yes. Okay, good afternoon. Can everybody hear me?
Yes, proceed.
Okay. Good afternoon. Thanks for giving us the time to hear our petition. My name is Yehuda Feig. I'm coordinator, or that would be chief of the Catskills Hatzalah EMS, Emergency Medical Services, our upstate division, which is a part of a division of New York City-based Hatzalah, which is probably the largest volunteer ambulance corps in the United States. We have a total of about 1,900 volunteer EMTs and paramedics. We respond throughout the 5 boroughs of New York City, and as well as the Catskills, which is Sullivan County and parts of Ulster County. We respond to about 70,000 emergency calls for service a year. And in Sullivan County, we're doing over 4,000 calls per year, and we are growing every year. As everybody knows, Sullivan County has a strong seasonal population that comes up from the city, which makes it very challenging to provide that level of emergency medical services when there's such a huge increase in population. So Catskills Hatzalah was formed about 40 years ago and has been growing since. We now have we operate 20 ambulances, all volunteer-based in Sullivan County, with a good portion of those in service year-round. So as of the last few years, and more so after COVID, we found that many residents that have just come for the summer are now staying there year-round. And we've been tasked with providing that level of service year-round now. So one of the challenges we've had was paramedic services throughout the winter. And with that, we have, in addition to about 40 members, EMTs, and 2 paramedics living in Sullivan County year-round that respond for us, all volunteer. We also have summertime, over 500 volunteers that respond to emergency summertime. Of those, we have about 50 paramedics. Many of them have homes in Sullivan County, but many don't. So we are now fortunate to have a donor that is building this garage for us, which will also give us the opportunity to allow for a paramedic to come up from the city every day on a volunteer basis to provide additional ALS coverage for us here for the residents of Sullivan County. We've been doing that for the past 2 years, but it's been a challenge to place these paramedics. Sometimes hotels, sometimes we have hotel that has long-term arrangements for us, but there's nothing like having our own home for that paramedic to come. So we will now have the room for a paramedic to come up and sleep in this new garage being built. We're anticipating to have a rotation of 1 paramedic coming, sometimes 2, and they will sleep in this new garage that's being built and respond out of that garage. Again, this is a volunteer that is coming from the city to augment paramedic services. So this is a real great benefit to us and to the residents we serve here. So basically, this is a satellite garage. Our main headquarters is headquartered in Fallsburg, where we have a large conference center. We have a large garage where we can house 8 ambulances here. Otherwise, we have them spread out in smaller satellite garages. But this location now in town of Thompson is centrally located for us, and this is the perfect spot for that paramedic that comes up. It's a central location, and it's a very essential service and spot for that paramedic to respond out of. So this would make it more comfortable and will help us attract the paramedics to continue to come up and provide this service on a volunteer basis.
Okay, thank you.
Any questions?
We'll hold the questions till after the presentation, okay?
Thank you.
Thank you.
Thank you. In addition to what Mr. Feig described regarding the solar soil, I'd like to read from the draft comprehensive plan that is in the town of Townsend that is currently being drafted. In their section of community facilities and services, it says, during the busy summer month, additional EMS support is provided by Townsend and Solar. Solar is Hebrew for rescue, which is one of the largest volunteer-based ambulance services in the United States. What originally began in 1984 as a small group of volunteers responding to medical emergencies for a few hundred families vacationing each summer in the Fallsville vicinity has grown into a full-time organization with over 300 volunteers and a fleet of 13 ambulances serving all of Sullivan County. We got to have the time correct that to correct numbers, 500 volunteers and 20 ambulances, I think he said. It says in 2012, Catskill Solar constructed a garage and dispatch facility in the neighboring town of Fallsville. Although they have an ambulance garage in Monticello, with Townsend's summer population growing and the demand for emergency medical services increasing, Catskill Solar is in the process of building a dispatch center on a donated property located on Alamo Lake Road in Monticello, which is the actual building which we are discussing now. So with that, we're here today to request a variance from the sprinkler system requirement for the ambulance garage currently under construction, which is on Fraser Road in the town of Townsend. As the chair mentioned, the building is a Type 5 construction and contains 3 distinct uses: the ambulance garage classified as an S2 occupancy, the office space, conference area, and break room, which is classified as a B occupancy, and the residential portion, which has 2 bedrooms and a bathroom, classified as R3 occupancy, with an area of approximately 450 square feet. Although the building is a Type 5B construction, the garage portion of the exterior walls, and as well as the wall between the garage and the other users, are constructed out of blocks. The sprinkler system requirement is triggered because of section 903.2.8 of the code mandates that any building with an occupancy, group R occupancy, to be sprinkled. However, there is no municipal water service in the area of the garage, and installing a sprinkler system would impose a significant financial burden on the organization. The cost is estimated at nearly $100,000, which funds that could be better spent on life-saving equipment without compromising the safety of the building's occupants, which is also an important public policy consideration for emergency services. In addition, there would be an ongoing annual cost for maintenance of the sprinkler system as well. As Mr. Feig said, the building will not be occupied on a daily basis. It will primarily be used by paramedics who do not have a home in Sullivan County, and primarily in the off-season during weekdays, because typically in the summer season you have enough paramedics, and in weekends during the year you also have enough paramedics. So it will not be occupied on a daily basis. The building will be occupied by trained emergency personnel who are familiar with the layout and evacuation procedures, and in the event of a fire, they would be able to evacuate quickly. The fire-resistant materials in the building, including a 1-hour fire-rated wall assembly and floor assemblies between the occupancies and additional black wall between the garage and the other occupancies, will help contain any potential fire before it can spread, allowing sufficient time for evacuation. The building will be equipped with smoke detectors as required in Section 907, and although not required in Group R3 occupancies, we will also have fire extinguishers in the residential portion of the building for immediate use should it be needed. Exit access travel distance from the most remote area of the residential portion to the exit is approximately 80 feet. The building is approximately 2.9 miles from the Monticello Firehouse with an estimated response time of about 7 minutes. The town of Townsend, who is code enforcement there, supports the variance request, although we don't have a letter from him. Our understanding is that he supports the request of the variances, as does the Monticello Fire Department. While their support was not in the original submission packet, we received a letter of support from the fire chief yesterday, which I do have some copies and an original if you want me to. And just give us one. Good. Sure. Do you want me to read it or?
No, that's okay. I just want to mark it as exhibit.
Sure. So it's part of it. Is this the original one?
Okay, so we're going to mark it as exhibit C. we can have this ready.
Yes, sure. This actually originally have a few copies if anyone wants. And this is supporting very much the requested variance.
Okay. Keep going.
There will also be a backup generator for the garage and for, for the entire building use in the event of a power outage, which will ensure that the building remains fully operational during the extended outages. Those are basically, my presentation, and if you have any questions, I'll be glad to answer.
Yeah, so we're gonna, go to the board member questions first, and then we'll bring in, Cornell.
Yes.
Bring him back up. All right, so, Shane, you want to start us off?
Okay, so you confirm that the wall separating the ambulance bays and the residential portion is a block wall, correct?
So the one outside of the assembly is actually a 2x4 wall with,
That's, but no, the question, this is between the ambulance bay,
yes,
right? That's block.
that is a black wall.
Perfect. Okay, so then where will the 1 hour firewalls be located that are framed?
Right behind the black wall.
Okay. And are any of the other assemblies 1 hour? Is the floor system 1 hour?
Floor system is a 1 hour as well.
Okay, so between the first floor and the second floor?
There's a 1 hour.
And I only see a break room. What will be in that break room?
Just snacks and, just for the volunteers that are there.
Is there a full kitchen anywhere? Will it be an oven?
There is not, there won't be a stove like
Yeah.
that. I mean, there will be a kitchenette, with stuff there. But
There won't be a
there
full,
won't be a cooking, yeah, it's not gonna be a cooking. It's actually a
On
photo.
the second floor, there is a kitchenette shown with a range.
If it's a range shown, it should be architect showed it, but, it won't be, I'm just gonna need for that place to have a stove, it's not gonna be.
You would agree that as a condition,
It's not a stove.
How can it be a residential unit without
It's,
Another
you don't have that.
dwelling unit, it's a sleeping unit, yes. Dwelling unit versus.
sleep? So then it's not hard,
Yeah, we,
okay, I'm sorry, Jake.
they're saying it's a concern. Especially for Valley Fire. So.
I mean, if we need to make this.
And the fire door then between the apparatus bay and the hallway?
That's cool, yes.
What will be in the stock room?
Typical supplies for ambulances, bandages, gauze bags, and other medical supply.
You won't be storing any lithium batteries or anything in that section of the building, right?
No, there's no need for lithium batteries, devices.
That's all I have now.
Okay, Mark?
Yes, I think I only have one question. I saw your Exhibit D was a quote for an NFPA 13 system. The New York State Building Code, Section 903.3.1.3 allows an NFPA 13D system for R3 occupancies. Did you price that out?
I wasn't involved in the pricing, so I understand what you're asking is if it can be a 13D sprinkler system versus an NFPA 13. I'm not sure if what they priced out was a 13 or 13D.
There was 13 that was priced out.
It says 13, right. I do not know if there would be any difference between the 13.
there would be a significant difference because the 13D system would have its own storage tank and pump, and you wouldn't need separate rooms for that. So there's lots of logic on why you go to the 13D system.
But it's
So I think that's all I'm going to have to say, Mr. Chair.
Shaheen?
Thank you. So I'll just start off by saying I think that a little bit more drawing should have been provided to clarify those fire rating requirements. So most of my questions are really just clarifications. The first thing I want to ask about is just the site grading and the exits that are shown. There's a door showing at the backyard out of the ambulance area, but it seems to be maybe 2 feet lower than the front yard, and there's no stairs displayed there. Is the site being regraded?
The site has been regraded around it.
So it'll be flat, right?
Yes.
Okay. So, and the reason I ask for my follow-up question is, could the residential occupancy have its own exit that doesn't require an intervening and combined corridor or lobby?
I think we did look at that. By the way, this is a photo from this morning.
Oh, cool. Okay.
So I just took a picture of it before I came in.
So really my question is, was it explored to provide a door on the back of the stair shaft out that way, and could that be an option?
We actually did explore that before I made a submission for the variance request. One of the things that I was looking at with the builders, and yeah, it was perhaps providing separate access, but it would be very costly and we would lose a lot of space internally for this, so we would have to make it larger.
Oh, I mean,
Yeah, but we actually have looked at it.
so you have a public record. So that was the first consideration that I was kind of looking at was, so you mentioned, so basically the separations are strictly a 1 hour rating. So you have a somewhat commercial occupancy from a residential occupancy. There's only a 1 hour rating between the two without a sprinkler. I don't know if that's maybe something we want to look at as well. I think typically a 2 hour rating is provided in those ceilings. So I'm going to also mention those two things that kind of jumped out at me, not having its own entrance and not being a 2 hour rating. I personally think the upstairs should have cooking. I mean, if you want it to be a unit, I think it should have cooking. I don't know if it was looking at gas versus electric, but if gas was proposed, I may consider looking at a suppression system if you're doing gas cooking upstairs. If you consider maybe a limitation on electric, I don't know how the rest of the board feels, but I think that may be something to explore. And then I was just, and my last point is, it would be nice to have a cross section as well, just to understand how the building is framed out. Can you just talk about the floor structure? Is it dimensional lumber? Is it TGIs? Is it like, how is the floor framed out?
So it was dimensional lumber.
That's regular lumber. Great. Okay, cool. So, okay. And, oh, sorry, you did have one more. And then, so, in the oxygen room itself, can you talk about the how much oxygen is stored in there?
So this is just to refill the supply for the ambulances. So they typically have their diesel. I'm not too familiar with these terms.
Okay.
I'm not a volunteer. Maybe I should be. So there are D cylinders and there are E cylinders. D cylinders typically have between 12 to 15 cubic feet of each, and E cylinders have 22 to 24 cubic feet each. The expected reserve is 3 of each of them. Yes.
And the room, does it have any additional, I mean, it's not accessible from the.
It's not accessible from the rest of the building, it's only accessible from the garage.
Right.
Yeah.
But do you know offhand, I mean, I'm assuming that room is fire rated and that the doors are fire rated?
The door is definitely a fire-rated door. I don't remember about the room itself, but the door is definitely a fire-rated door. These are way below any one of the limitations, at least one of the limitations for oxygen is 1,500 cubic.
Okay.
So this is way below that.
And is there any other fuel storage on site, either for the trucks or other machines or?
So the ambulances are being fueled within gas stations, but there will be a propane tank behind the building or beside the building for there's no natural gas available out there in Sullivan County.
And that propane tank would just be installed in accordance with the fire code, if you want to look for any additional.
When I look for any variances for the propane tank, which is, is very typical on standard out there.
Agreed.
Thank you.
Okay, Megan?
Yes, so, one question in the submission that we received, the estimated sprinkler system cost was about 82,200. You said 100,000.
I said estimated near 100,000. If we need to add a sprinkler system with storage, we will need to have additional room for that as well.
Okay.
So, and I think having the submission, like an additional square footage to the building.
I see, I would, okay, an additional 16,000.
That's why I said,
Okay.
estimated near 100,000.
And what is the overall cost of the project?
It's approximately $750,000.
My other questions had to do with the attic. There was attic mentioned in the submission, and the photo that you just showed us of the construction underway shows the dormers and windows. Is the attic occupied?
So there's no attic, there's attic space, just the trusses above the garage, but these are just dormers. So there's no attic. And this is for the second, and this is the second story, with the residential portions.
Okay,
It's not
so
actual attics are not occupied.
in the sprinkler description or the estimate, it mentioned a number of heads for the attic space. So,
My assumption is that the sprinkler engineer required heads in the attic, that would be my assumption, because there may be some mechanical equipment.
okay, but otherwise unoccupied and inaccessible.
By code, we have to have access to it. But just access, just an access panel. Not that we have access to it.
I also had a question about the stair exiting directly outside. Had any thought been given to putting the bedrooms on the ground floor and the other spaces above?
We were not really exploring that, but as I'm thinking about it, operational wise, it would make sense for the residential portion to be upstairs, as it's not going to be used as frequent as, the rooms that are downstairs. Like the break room and the staff room, those are really frequently used on a daily basis. The upstairs will not really be used as much.
That's it for me.
Okay. And it's mentioned it's a volunteer fire department.
So Monticello Fire Department they have, I think, a total of 6 or 7 career fire members, which, shifts. So I think 2 or 3 of them always there 24/7, and they have a volunteer of 50 plus. Yeah, they do have 2 or 3 on call in their firehouse.
You mentioned a emergency generator.
Yes.
Where is that located? See, what's that listed?
It's going to be outside, obviously. I'm not sure on which side the building will be. We did not show it on the side.
It'd be up against the building or maybe off the side.
To be closer to the building, I mean, not in front of the building, either the side or the rear.
Fuel by what? Propane. Already. Can you give me any idea of how the lack of the sprinkler system would impact the insurance premiums on building?
So the CAT's Hudson is part of, as Mr. Mike says, part of the New York City division. I mean, this is the CAT's division of the Maine. They do have a huge policy on all of their buildings and equipment. So if there will be any difference, it will be very negligible. We actually did look at that.
Okay, so then the last thing is, obviously, you're here applying for a variance, the building has already been permitted, it's substantially constructed. How did we get to this point where we're applying for this variance if the building's almost, partially constructed?
So good question, great question, actually. We have permitted the building, we actually have a sprinkler system design. And when the organization got the cost of the system, and we were limited by whatever the donor amount is going to be, what he's going to donate for the building, and that extra cost would basically be on the organization, which would place a huge burden on them. So that's when, in the middle of the construction, they decided that they got the cost for the sprinkler system, that it's just like 450 square feet residential portion, which is not really a house, but more for the paramedics that come up and sleep there. So they decided to, that it makes sense to go for that.
Okay, any other questions before we move on?
I do. Could you just, one of your categories for applying for the variance is alternatives. I just want to revisit the list of alternatives here under item 2 under exhibit A. Could you please go through those again and explain which ones truly are alternatives that are above and beyond or different from actual code required items? You mentioned smoke detectors, which was code required, but it's listed here as an alternative. So I just want to be clear about what you're offering, what the alternatives are that you're offering.
We might have included, I mean, you're right, number 2 talks more about alternative items, so we included required items and alternative items. So smoke detectors is required to be in the building regardless. Fire resistant building materials, some of them are required. What I mentioned is we have more because we have a black wall as well. Fire extinguishers are not required in the residential portion of the building, I mean, in the sleeping unit, but we will be providing that too. Exit access travel distance is 80 feet. And that is just a fact. Not that there's going to be any additional training for them, but they are trained personnel who are going to be sleeping in these units. They know how to act in emergency situations, and they're very well aware of the situation where they should be, and they should be able to respond quickly.
Can I ask a question? When you say they're trained, are they only EMS or are they firefighters as well?
There are actually some firefighters as well. I mean, most of them are probably not firefighters, but the EMT, a lot of them are firefighters. I don't know,
So then-
around firefighters as well.
Okay, so some of them may not be trained in the
Not
fire.
trained,
I'm
not trained in a fire.
Exactly, so I think that's needs to be more, clarified, because you could know a firefighter, but that doesn't mean you're gonna have the skills to know what to do in a fire situation.
I mean, mainly for fire situations, is for them to evacuate.
I had a follow-up question about the fire alarm system. So could you describe the fire alarm system in the building, unless I missed it? And is it connected to a central station? Is it just local?
I'm not sure if it's connected to a central station.
Is that something that they would be willing to do?
Use it? The mic? Oh, we can't hear you, you gotta mute it.
You mute it out.
Don't crash.
We can't hear you.
Still muted.
You're muted.
Okay, how about now? Better now?
Good now.
Okay. I couldn't hear that question clearly.
So the question is, the fire alarm system, willing to have that connected to a central station?
If we would have to, if we would have to, we can do that. As emergency responders, we all hear all these false alarms daily for these automatic fire alarms with notification of the fire department. But if that would be the requirement, I'm sure we would be able to accommodate.
Okay, thank you.
You're welcome.
Good. Everybody else is good? All right, so we're going to move on to comments from public, but I know that I see that we have Mr. Carnell on, who is the code enforcement officer. Mr. Carnell, are you there? He was there earlier. Let me unread my mic.
If it doesn't do before that, you'll have to go to the meeting, so.
Mr.
Carnell?
All right. So,
I see you just texted me 10 minutes ago that the whole thing was.
Yeah, no. All right, so at this point, we're going to open it up to the public. Is there anyone here present who would like to speak regarding this petition? Okay, not hearing anybody. Is there anyone who is joining us remotely who would like to speak to this petition? Okay, not hearing anybody.
All right, so can you hear me?
Oh, yeah. Okay, there you go. Okay, Carnell, would you like to say anything regarding this petition?
Yeah, we have no objection to the request for the waiver on the sprinklers. The building, the way it was designed, the ambulance services are in a brick building that's separation from the residential portion of this. The wood frame structure that is the residential portion, and then again wood frame roof on the brick or the service base where the ambulance is going to be. And because the occupants can be limited to either 2 or 4 per shift, it's not like they have a lot of people in the building. They're going to be familiar with the building because they're going to be on recurring shifts here. It's not going to be strange people coming into the building all the time.
Is there anything else you'd like to add?
They're just the organization is an asset to the community. They provide great service for not just the residents of Brooklyn, but all of Sullivan County.
All right, thank you very much.
Okay, sorry earlier, but I did have other appointments and I had to step out. So I do have somebody in my office with me, so I appreciate the patience. Thank you.
Okay, so at this point, we're going to go into deliberations. So we're going to go, Winston, we're going to roll the record. Barbara, we're off the record. Okay. Okay, we're back on record. I understand you have a request.
Yes, so I'd like to request the board to, if we can adjourn this, and we'll provide more information before the meeting.
So the next meeting would be what, October 14th?
Yeah.
It'll be October 14th, and you would need to get, what is it, 2 weeks prior, Neil?
Approximately, yeah.
2 weeks prior to that meeting, you need to get all the updated information to, okay?
The only issue that October 4th will be an holiday for us, so I won't be able to make that. Is that a firm date, October 14th?
The second Tuesday, it should be.
So I guess.
We can discuss that. I mean, as of right now, it's where we can see if we can, change the date.
We have other cases already, don't we?
I don't know.
We have other cases already.
Yeah.
What,
I would be available.
Well, I don't know how it's gonna affect, I don't know how it's gonna affect other applications, I don't know how it's gonna affect the availability of this room. So we have to find that out.
How long?
What's the holiday?
What is today's holiday?
It actually starts with
No.
7th.
it's,
Jewish holiday?
We'll have to get back to you on the possibility of changing the date. All right? Because this, just as everything, so we'll, yeah. Okay. Thank you. All right, so we're off the record. We're off the record, Barbara?
Yeah, we're off the record.